not wood as a primary material, which is called Adobe, and also some reinforcing agents and binders which are locally available to build the houses for the local people. So also in this research work, we try to use the locally available straws for as a reinforcing agent in this current research. So these are the different type of straws, available in Ethiopia, like rice straw, tape straw, etc., etc. We actually verified these straws. We tested these straws for their tensile capabilities. Finally, we actually took the best one, which is available in Gambela. Moving to the problem statement, I think I have already covered it. Because of this, traditional house construction technique, it is leading to deforestation, and also the normal temperature is being shoot up. So these are the issues related to deforestation, and also soil erosion is a big problem because of the deforestation. So these are the issues basically, and also these earthen houses are very poor in durability. We could often see there are shrinkage cracks and also termite mound attacks at the bottom. We could see. So these are some problem statement. So we could see these are the problems related to the conventional houses. So objective of this research. So the general objective is obviously to try this new construction technology called Adobe in place of the conventional construction technique, chica beds. And from specific objective perspective, we have to identify the best, binder and the type of soil. We have to understand the type of soil and the best suited binder for that particular soil, because you cannot generalize the binder based on the soil. You have to fix the binder. So the soil, the type of binder, and optimum quantity of the this reinforcing agent and the binder has to be chosen. So these are the specific objective. And finally, we had to to prove this Adobe as a construction unit, or mud block as a construction unit. We actually had to identify the strength and durability properties. So the second objective was to identify the strength properties of these Adobes. Second was to identify the durability properties of these Adobes. Moving on, materials and experimental procedure. So we actually took the locally available mud, which was actually in Gambela, you would see a lot of termite mounds, and we took the soil from these termite mounds and locally available fibers, and we choose actually the perfect binder for that. And soil actually, we actually tested as per the standards, ASTM standards, to understand which type of the soil it was. And based on the type of soil, we had to choose the perfect binder for that. Okay, and we actually then we actually added those straws into these mud blocks in different volume. Then we actually came up with many test molds. Then we tested for their strength and durability properties. So I just wanted to show you, probably this will be interesting for you, how did we proceed. In this research project, my learning was, whenever we do any kind of research project, the community acceptability is very important, because you do some research and finally the community doesn't accept it. So it is very imperative that we speak to the community and make them understand this is what we are going to take. That's what we did actually. And another interesting thing was, from them you get to know a lot of knowledge. Maybe they're not, technically they might not tell you, but from their experience they could say this would be the best solution, this would be the best solution, and that actually helped us. So we met the community, and we told them that we are going to do this work, and which type of, where shall we take the soil basically, which one you would prefer. They said we only would accept the termite mound soil in Gambela, because people believe only termite mound soil in Gambela. Then it was to surprise, we actually did a testing of, XRD testing of the normal soil and termite mound soil. And obviously we found that it was better, from the chemical perspective. So that helped us. And the second figure I just showed, the durability problems we found in, the local houses. And then these are the local straws we actually collected, and these are the termite mounds actually plentifully available in Gambela. We took the soil from there, and then these are the soil procurement. Then we took all the soil, because of the unavailability of the laboratory facility. We had a tie up with IBAT in Addis Ababa. We took the soil to their laboratory, and we actually did proceed our work. So these are the first, we did prepare the soil. Then it was very important to know the type of soil, so we did conduct a lot of studies on soil to identify which type of soil it was, and we found that it was uh, 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 a red soil basically, and from there we found that the best binder would be cement OPC. So we choose OPC. Then okay, sorry. So the next one is actually we got the straw from Gambela. We had to understand its tensile capability. So we also tried, to understand the tensile strength of the particular straw, which is about 6 MPa. Then actually we did try added these straws in different portions like 1.5, 2.5, 3.5. So I just cut down those to the required aspect ratio. And the next one is mixing. We mixed all the constituent materials. Finally, we came up the second figure. If you see, it is very interesting. It was a field test basically for the understanding the plasticity. Has to be released from your waist height. If it doesn't, the ball doesn't break, then it was the right, water content. So we did this study. Finally, we mixed all the Adobes, the straws, and finally we came up with those soil blocks. So this was our preparation of the soil blocks. Then we had to go for the testing of the soil. So as I told you, we had to do the strength testing and durability testing. From the durability perspective, we first conducted the shrinkage test, then water absorption test, then capillary action. We did prepare all the setups as well, where we tested the capillary action, how the water is getting absorbed by capillary, then so on. Then finally, there are a lot of tests actually as per the core book we followed, which mimics different environment condition. What are the durability tests are basically which mimics different environmental condition. For example, your house may be exposed to heavy rain, may be exposed to your flood, may be exposed to drizzling. So you have, if you want to understand how would be the impact, you have to test different tests. So we took all these things from the code book and we tested. So this is basically one test which actually talks about how the Adobe behaves under high pressure, basically high pressure water. So moving on, this is the compressive strength test which we conducted and water strength we conducted. So these are some pictorial representations. Finally, quickly, cautious of time, I'll quickly move on and speak about the results and discussion. As I told you, first we did the soil test, and we found that it says CL soil, and from that CL soil we understood that the best suitable binder was OPC. We must understand here, if the soil is varies, you have to choose another type of binder. So binder is not constant. Some places you would see lime would be a good binder. For CL soil, what I say, OPC was the best binder. Then we did soil testing. Then we found that the optimum percentage of cement should be 2.5 percentage. Okay. So we conducted the standard proctor test and we finalized that 2.5 percentage would be the best optimum, cement which should be added. Moving on for compressive strength, as I said, we added these, straws in different ratios, and we tested their compressive strengths. We found that at soil and 2.5 percentage of cement and 1.5 percentage of the straw, we got the optimum percentage of compressive strength. So from compressive strength, that was we took as the optimum. Moving on, water strength test. In water strength test, this is basically a test which shows when a soil block is completely immersed in water, how much it is strength loss. So these are the strength loss we found, and the strength loss is basically decreasing when increasing when we keep on increasing the amount of straws. Then durability test, as I told you, we conducted several tests, but for the paper, I am only presenting two outputs because of the limitations. These are the different durability tests we conducted, which actually mimics different environmental conditions. It's very important to conduct all the tests. So we'll see what are the tests we actually conducted. One source about how moist conditions, how alternate wetting and drying, how the heavy rainfall impacts. So these are the different tests we did conduct. And finally, the shrinkage one, obviously for reduction of volume of the blocks we conducted. And from the water absorption perspective, obviously we could see the water absorption is kind of decreasing. It is only because of, we actually conducted a mineralogical and chemical test. We found there are a lot of, clay contents. Because of that, it is actually decreasing. The water holding capacity is increasing basically. And shrinkage test, obviously, we could see the reduction in volume is decreasing basically, which is a very good sign for us. There would be a reduced shrinkage if we use these Adobe blocks. Finally, I'll conclude this. Uh, when you compare normal soil and termite soil, obviously termite soil would be the best preferred one, because the termites kind of releases some saliva from their mouth, which is basically add some strength to the adobes. That was the first take from our side. Then cement was the perfect binder for our adobe, because considering the CL type of soil, and 2.5 percentage of the cement was optimum from the standard proctor test we found. Then how much this reinforcing agent has to be added, that was 1.5 percentage. You could see still people are using these straws like tape straw, etc in the chica beds, but they don't know how much to be added. They would just add whatever they want, but that has to be scientific. So we found that 1.5% is the optimum. And so that was the optimum. And our durability test results showed that with the inclusion of these reinforcing agents, obviously the durability is getting enhanced from the strength perspective, from the shrinkage perspective, and absorption from the capabilities perspective. So finally, utilization of these blocks would definitely help us in reducing our deforestation and also soil erosion. So with this, I finish my presentation. Thank you, everyone.